Hi, I'm Dennis di Cicco, Senior Editor of Sky and Telescope magazine here at the 2011 Northeast Astronomy Forum. And right now I'm talking with Tom Field, longtime amateur astronomer and the author of RSpec real-time spectroscopy software. I think most of our viewers have a good idea what spectroscopy is all about in its basic form. You take white light or plain light and feed it into a prism or a grating, and it gets broken up into a rainbow of colors from the red to the blue, and you can analyze those colors and learn an awful lot about those astronomical objects. What a lot of viewers may not understand is just how easy it is for amateur astronomers to do this in their backyard with very simple equipment. And to that, Tom, I'd like you to tell viewers just how easy it is to get started and to do all of this.
Sure, Dennis, thank you. Several years ago, I wanted to get into spectroscopy. I was curious what I could do with my telescope that was a little bit more scientifically oriented than simply imaging. And I picked up, this is an inexpensive grating, it's a star analyzer grating, and I screwed it onto the front of my, I just had a webcam at that time, screwed it onto my camera, went into the backyard with my SCT telescope, and what I found was that I could capture really interesting data just in my backyard in an urban location.
Just with a webcam and this grating attached in a telescope.
Sure, exactly.
All
yeah,
right.
it just screws right onto the telescope, and then when you look in the telescope, you're actually going to see the spectrum, which you can capture on your camera.
You were saying you wanted to do something a little bit more scientific. Did you have a lot of experience with imaging beforehand?
I hadn't done a lot of imaging, I'd done some, but it didn't really capture my imagination the way it does for quite a few amateurs. I found the subjective quality of the images, it was exciting, but the fine-tuning after a while, it just wasn't capturing my interest.
All right, so you said you had a webcam and an 8-inch telescope. Can people do this with other equipment?
Oh yeah, absolutely, Dennis. I just happen to have a webcam handy from some other work I'd done, some planetary imaging. But whether it's a webcam or, you know, this is an imaging source camera that I've used, and these work really well. Some of the best amateur low-resolution spectroscopy is being done with these.
So you just put the grating into the nose piece and then drop it into your telescope?
Yeah, this is it. You just sort of screw it right in, right just like this, and that's all there is to it, really. It's pretty easy.
All right. What about if you've got, just say, a DSLR, maybe not even a telescope, DSLR, maybe a telephoto lens. Can you do work with that?
Yeah, what you do is you just take the grating, put it on the front of the lens, just on a lens cap. You can just cut a hole in the lens cap, and then you can actually do imaging of brighter images.
Just set it on a tripod, take a couple of snapshots, and boom, you've got a spectrum.
In fact, you don't even really need to track on the brighter stars, because if you orient the grating right, the tracking and the smearing will contribute to the image.
All right, and I take it you can do this if you've got a color camera or even a black and white camera. It really doesn't make any difference.
Doesn't make any difference. The color works fine. Again, for higher resolution and more accurate work, of course, we want to use mono because it's more sensitive also. But a color camera works as well as a mono for the kinds of imaging that we're typically doing.
All right, so it's relatively easy using equipment that you've got to go out and get a spectrum, either a video or a still image. What do you do with it then?
Well, that was really a challenge for me. When I first went out on that first night, the next morning, when I tried to reduce my data and actually get a graph of the spectrum so I could interpret it, the software that was available just wasn't making it for me. I had trouble learning to use it. I couldn't get what I wanted to get done.
All right, so you had this an image of a spectrum, and you wanted to be able to plot the brightnesses where you could see bright lines or dark absorption lines, get a little line plot of that spectrum.
Right, we wanted to go right from the color rainbow to a graph that we could then examine and actually look at objective scientific data. And so the process of getting to the graph was so cumbersome, I decided I'd put together a little prototype piece of software for myself that would allow me to do it effectively.
All right, so I want to step back for a second and ask you, what kind of objects could you record with this simple setup, with your webcam and an 8-inch telescope?
It's remarkable what you can record, actually. I got images of Vega. I could see the hydrogen absorption lines right in the graph that I was getting. You can look, for example, at the atmosphere of Uranus or Neptune. You actually see the methane bands, the absorption bands of the atmosphere. Now this is from an urban location right in my backyard. This wasn't a dark sky site.
Light pollution isn't a big deal.
It's really not much of a big deal. In a spectroscopy, since we're spreading the light out and we're not as interested in the color balance and all of those subjective issues, light pollution hasn't nearly the impact that it does on visual imaging.
Astrophotography, yeah.
Yeah, astrophotographers, these days with the increasing urban light pollution, it's really been a challenge for them to get the really good images from the urban locations. And the other thing is, astrophotographers these days, I think they've been looking for additional challenges in addition to the visual imaging, and spectroscopy is a whole new field they can get into. It's got lots of challenges, and it's got lots of rewards. It's very exciting.
All right, so we're back to now what you're going to do with the images after you've got them.
Sure, what we do is we feed them into the RSpec software, and in the software we see the image. One thing I wanted to mention, Dennis, this can be a webcam, it can also be a FITS file that's come from a classical astronomy CCD camera. So most any camera they have will feed this image into the software.
And this is the software you've developed.
That's right, it's the RSpec real-time spectroscopy software. And you can do it real time, you can do it the next morning. When you feed the image in, you can see the image, and then right immediately to the side, you see a graph showing the scientific profile of the data that you captured.
What can you run this software on?
Well, it's a Windows-based program. You can run it on laptops. The fun thing is on a laptop is you can actually get a spectrum out in the field, see the color, show it to other people, and confirm that you're getting the data that you want. If you want to, you can just capture the data on your FITS file camera and then later just run it on a desktop machine in the house.
So if you've got a webcam and you've got a real-time video on your screen, you can run this in the field and actually see the spectrum lines as it comes off. Can you give me a demonstration of the software?
Sure, let's take a look.
All right.
So here we are, we're running the software, and this is a typical real-time screen that we'd see.
All right, so what have we got over on the left here?
So this is our star, and this is the actual spectrum that came from the grating. We're in mono here. It would be color if we had a color camera.
All right, so you're looking at this as a real-time video. All right, so where do you go from here?
Well, the first thing is we took our image in the diagonal because our chip sensor size may be relatively small. So we can use this rotate box and actually rotate it around till it's horizontal. So now we've got it horizontal. Let's just tweak it up there. And now I'm just going to drag this capture box into place to tell the software that's what I'm capturing.
Oh, wow, so now you've got a spectrum over here.
That's right. This is the graph. We're actually vertically binning each of these columns and displaying it. So this peak here is the star.
Yeah.
And then over on the right, this is the spectrum. And you can see that dip right there. That's actually an absorption line from Vega.
That's a hydrogen absorption line.
That's a hydrogen
absorption.
absorption.
You've already got your calibration here for your wavelength and angstroms.
That's right. Well, I went through one step to go from pixel to angstroms, which is a simple step. Then the software can synthesize the spectrum. And then if you're using a webcam, you can click on this average button here, and it will average successive frames. If you're using a CCD camera and processing your own FITS images, you could stack them outside the program and then bring them in batches like this.
Boy, is that easy to do.
Yeah, it really is. See, now I can actually hover my mouse over that feature, I can see the wavelength, or I could actually bring up a list of the hydrogen bomber lines, and I can see that all of these reference lines correspond to the dips that I saw in the software here from my backyard scope.
All right, so wait a minute, let me ask you a question here. You've already got reference lines where they belong at a rest wavelength. What happens if you get, can you do a quasar with this?
Yeah, you can. It's remarkable, and it surprises just about everybody I show. In the backyard, for example, the first example I saw was in a backyard outside of London with a modified security camera. An amateur I know was able to capture 3C273 and see the red shift. It actually shows up right on the screen.
Because you see that the wavelength is displaced from the standard wavelength.
That's right. In fact, what he did, and what I've seen amateurs here in the US, Germany, all over the world, this isn't just one guy who's really good with a mountaintop observatory. He took a Vega image and compared it right on the screen, and he could see the shift of the absorption line.
All right, so that's amazing. So you could see the shift of a quasar.
Yeah, it startles just about everybody I show it to.
That's amazing. You have a website.
That's right. We've got a great website. It's got a collection of tutorial videos that actually come with the software. It's about maybe 20 or 30 videos that are 2 or 3 minutes long. Actually walks the user screen by screen live through the process of using the software.
All right, so they'd be able to see the type of demonstration we were just looking at here as well as a whole lot of others.
Oh yeah, there's lots of tutorial videos.
Well, what's the website?
The website is RSpec, RSPEC-astro.com.
That's easy enough?
Good.
All right. Well, listen, that's great. This has got all kinds of potential. It's so easy to do. Could schools do this with simple equipment?
Yeah, what a school might do if they don't have a sophisticated camera, but maybe they have a telescope already, they can just buy this is a Celestron, it's an $89 camera you can get on Amazon.
Little webcam.
Yeah, screw the grating in and then into their telescope, and they're good to go.
And where you've got this real-time equipment, you can watch these spectra. You can do it right there in the classroom, for that matter.
That's right. They can take an image. Now, what I found is that when you hand a student a piece of paper and it's got a dull graph on it, a teacher doesn't get the kind of response as if, for example, they have a real-time display where it's changing. The kids today want to see things move, they like screens, so that's what they can do with just a simple camera.
Real-time astrophysics right in front of your eyes.
That's exactly right.
That's great, Tom. Well, listen, thank you very much for showing me about this, and I'll certainly be looking forward to seeing you perhaps next year at the 2012 NEAF and what you've done since then.
Thanks, Dennis.
All right. Hey, can we take a look at some of the other stuff that you've got here?
Yeah, look at this.
All right. Which one have you got?